In maths at the moment, we are looking at location and transformation, and today we are focusing in on transformation. So, transformation changes the size or position of a shape, and there is two kinds that we are looking at today. Enlargement makes a shape bigger, and reduction makes the shape smaller. We use a scale factor to determine how much bigger or smaller a shape will become. Now, the scale factor is always represented as a number. So how can we use scale factor to find the missing lengths of similar shapes? Now, if you have a look on the whiteboard, I've got a red triangle and a green triangle. We can see that they're very similar shapes, but by eye we can tell that the green is bigger than the red. But how much bigger is it? So what we do is we look at the corresponding sides of the similar shapes. Now, the numbers are different, so it's important to look at which sides match. So I can see that this long line here matches with that long line there. Similarly, I can see that this diagonal line of this triangle matches up with this one. Now, to work out the scale factor, all I do is I need to figure out by what number do I multiply 2 by to get to 4. Then I need to check, if I multiply 5 by that same number, do I get to 10? So I can see that the scale factor for this shape is going to be 2, because 2 times 2 equals 4, and 5 times 2 equals 10. So I can write scale factor is equal to 2. Now that I know what my scale factor is, I can use this number to figure out what this missing length equals to. All I need to do is find the matching length on the opposite shape, so here, and I simply do 3 multiplied by 2, and I know that that equals 6. So the missing length must be 6 centimetres. We can also use scale factor to find 2 missing lengths. We can see we are missing a length on our little triangle, and we're also missing a length on our bigger triangle. But remember, we can look at the corresponding lengths to figure out the scale factor. So I can see that this line here matches perfectly with this line here. 35 millimetres and 7 millimetres. So to work out the scale factor, I need to figure out what do I multiply 7 by to get to 35. I can also set this out as a division equation. My times tables, I know that 35 divided by 7 equals 5. So my scale factor must be 5. Now that I know my scale factor, I can use this to figure out the missing lengths. We can see that 25 millimetres runs along the base of the triangle here. So I need to divide 25 by 5 to find my missing length. 25 divided by 5 equals 5. So my missing length on my small triangle is 5 millimetres. I can then use my scale factor to work out what this missing length equals. So this line matches up beautifully with my 4 millimetres over here. And because this is getting bigger, I know I need to multiply by my scale factor. So 4 multiplied by a scale factor of 5 equals 20. So my missing length here is 20 millimetres. We can then use our knowledge of scale factor to draw new shapes. So let's have a look at this question. Draw the shape 2 times smaller. I can see I have a rectangle with a length of 6 centimetres and a width of 2 centimetres. So we need to divide our side lengths by 2 to make the shape 2 times smaller. So there you have it. I divided my side lengths by 2, and then I drew my correct shape 2 times smaller than the original. If we were then asked to find what the scale factor was, we can't really just say that the scale factor is 2 times smaller, but we can do some simple equations to work out what the actual scale factor is. All we need to do is figure out what 3 over 6 is as a fraction, and you can see that that is equal to 1/2. Therefore, our scale factor is 1/2 or 0.5. But what happens when we are given shapes and we're not actually given the side lengths? It's just a shape drawn on grid paper. Well, we can actually use the grid squares to figure out the scale factor for each shape. I'll show you how to do that now. Here we have two very similar shapes, and we're going to work out the scale factor by using the grid squares. Let's start with this side length of the small arrow. We can see that that takes up half of a grid square, so 0.5. Now let's look at the corresponding side on the larger shape, and we can see that that takes up 1.5 grid squares. Now we have our side lengths, we need to figure out how many times we need to multiply 0.5 to reach 1.5. We can set this out as a division equation. 1.5 divided by 0.5 is 3. We can check this scale factor by looking at other side lengths. So, the base length for the small arrow is 2, and the base length on the bigger arrow is equal to 6. 6 divided by 2 equals 3 as well, so therefore our scale factor must be 3.